Okay, so this is week 5. We'll talk about pipe cutting and threading. So we'll do at least one cut, one thread by hand, not by your own hand, but by hand tools. And one cut and thread by power tool. And you can see the difference. If this is going to be your career, probably you will need to invest into some power tool because it's a lot of labor involved. When I did that a long time ago, as a plumber, we had a tripod, that was it. You just get a tripod that holds your pipe, and it's all like bits and hand tools. So it gets a little bit involved. Yeah.
Would be like doing some of that like on the site or not?
You will do that for your boiler. So the plumber has to do the plumbing all the way to your boiler. Good question, guys. In the field, you cannot do any indoor plumbing for the house, but you can. The plumber, same with the electricity. They put the wiring all the way to the switch, and you continue your own thing. So the plumber will come and plumb the pipe all the way to your boiler, and this is yours. That's why you need to do some cutting and fitting, because you gotta do hot water. So you'll do some for your boiler within your rig, but you don't do anything with the house plumbing. If you decide you did the wrong plumbing or the wrong valves, you can ask them to change it. But it's not your responsibility because again, you have to be a licensed pipe fitter. Gas, you don't do gas. Gas plumbing is different. You have to get a licensed gas technician to come and do the pipe fitting for you, and you only can plug your equipment. So the same thing. Okay, let's talk a little bit about plumbing. What is plumbing? So plumbing comes from the word plumb. What does it mean?
Well, I know what it means.
No.
Means it's perpendicular to the
No.
floor. Well,
So-
what's a plumb wall?
PB is the symbol for what in the periodic table? Who said lead? Yeah, it is lead. So plumbing came from the word lead because pipes used to be made out of lead. Why lead? Not because it was soft. Before they found it's very bad for your health. Lead is easy to work with to make pipes. Before lead, what did they used to make pipes with?
Clay?
Clay.
Really?
That's 3,000 years ago, the Roman Empire. They had plumbing all made out of clay and channels. So clay, cement pipes, big pipes are made out of cement. There are pipes that you can drive an SUV through, like sewer drains and stuff like that. They're made out of cement. So what else? What for HVAC? What do we use for piping? Either galvanized steel or copper. Now there's no popular pipes that look like hoses.
Oh, PEX.
PEX are becoming common. They're basically kind of stiff hoses, which you can run through the house. They are not the best thing, but they're very convenient and inexpensive. How pipes are made? Just a quick question you have to know. I mean, if you were stranded in a desert island and you had to make a pipe, what are you gonna do? Yeah, you're gonna bring a sheet metal and fold it and weld on the top. Or you can use a long sheet of metal and twist it around, spire it and weld the seams. If you look at the HVAC duct over here, it's a big pipe made out of strip. You just swirl it around and go around and twist it. It's how they used to make pipe back in the days. They still make pipe this way, large pipes. You can sometimes see the seams. And for the small little pipes, they just cast it.
Are you talking about the flue pipe?
Huh?
Are you talking about the flue pipe?
Yeah,
Oh, yeah.
any kind of pipe. What are they made of? Steel, zinc, carbon steel. So a lot of galvanized steel pipes are made of combination between iron and carbon. The darker the color, the more carbon there is. And the way it is treated, by treated being like heated and cooled and mixed, determine the stiffness of the pipe, how much pressure it can take. If you notice, the more iron you have in the pipe, the softer it is. It's gonna be soft, so you can cut through it, you can see it actually being sheared. That's a soft pipe. If it gets harder, that means it's steel. Stainless steel has grates, it's stronger. There's a drawback to adding carbon to iron. It makes it very stiff, but what else happens to it?
It gets oxidized?
No,
I think it's brittle.
it gets brittle, which means it can break. So car engine is made out of cast iron, very, very malleable. So when you never heard of like of a engine block bending or something, it's just gonna break and crack. Cast iron is so hard, it to withstand a lot of pressure, but it's not malleable. It's not going to bend, it's going to break. So this stuff you break. Zinc is another component they put in it, carbon steel, and there are other alloys depending on the utilization. And all pipes are rated based on what are you going to use in them. So if you're going to use water, there are some certain pipe that you have to use with water. For drinking water, what do we use? Sometimes what is it called? PVC. Or if you want to really be.
Sometimes plastic is not good because when you have hot water run through,
But they have one rating for hot water. But if you go to old houses built in the 60s or 70s, they had copper. So somebody went there and started a lot of copper pipes for water. Because copper is clean, even when it oxidizes, it's not bad for you. It's not toxic. The green stuff is here on copper is not toxic. Issue with piping, corrosion. If you open the faucets here early in the morning, what color is the water?
Brown.
Brown. It's mostly oxidized steel. This pipe has been here for hundreds of years or so. Over time, they will oxidize. And they had different technology back then. So that is corrosion. Material been oxidized and it goes into the water. Erosion. What is the difference between corrosion and erosion?
Well, erosion is how land is, it kind of degrades over time. Corrosion is
Okay.
when, like, pipes rust. or
Okay,
so.
very, very close. Very, very close. So what he is saying is when a piece of the material is gone, that's erosion. When it's oxidized, that's corrosion. So what is the key idea? Corrosion is chemical. There's a reaction. The material has reacted, became a new material, and it moved away. Erosion is mechanical, something being chiseled away over time because of particles. So I'll write this down just for information. So this is the main difference between corrosion and erosion. Also, we have some kind of buildup in scales. So if you're dealing with hot water, depending on the surface of the pipe, there is some kind of scale. Where does scale come from?
Lime.
From lime, from the water. It's if you have water, you're gonna have some scale, because water has some salt. Over time and heat, it will start to build up. Why do we do reaming in the pipe? Why should we try to make the pipe as smooth as possible? Because if there's crevices in the water, this is where you're gonna start having deposits of lime, of salt, of debris. It's gonna accumulate there. What else can we have? If we have oil as a product, what would be the deposit there? It's not gonna have corrosion. You're gonna have a lot of sludge.
Yeah.
Sludge, because oil is organic material. When you get some water in there, you're gonna have some bacteria, you're gonna have some sludge, it's gonna clog the pipes. So expansion and contraction is another issue we have to think about when we do piping. Pipes are made out of metal, metal expands and contract, and that's why a lot of times when you see long piping, you will see the pipe goes up and there's always elbows. They don't like to make very straight pipe between two rigid surfaces. So if you have two tanks, they always tell you to use something called a swing joint or an elbow, or an arrow.
That's what connects them.
Yeah, and why they're doing that? That's for expansion and contraction. When it's cold, it's going to shrink, so it look a little bit like this. It's hot. It's gonna look like that, kind of squished together. Sometimes it's visible, sometimes it's not. If you go to the east-west pipeline, like between states, for like oil line and stuff, the loops are big and actually you can sometimes see them bend a little, small degrees. They bend these calculated bits in the expansion of the pipe. It cannot be too much. If it's too much, then it will break the pipe. And the contraction and expansion over time will also fatigue the pipe. So it has to be well calculated. That's something pipe fitters actually also learn, but not for residential. So, pipe information, material is one thing, ID and OD, that's very important. What is ID?
Internal diameter.
I'm gonna write it down. So, actually I'm gonna
Or inside.
draw a picture. So this is OD, outside diameter. This here, okay, and this is the distance for it. Inside diameter. And this here is what? T, thickness.
Thickness?
Yeah, how thick is the pipe? So when we do the lab with galvanized steel, there's something called a nominal diameter. Nominal. What does nominal mean? If you have to just think out of just the meaning of the word.
Like non-existent kind of?
General?
Close. What else?
General?
General, or what is known for, what is called after. So this is the, how can I say, give me a synonym for that.
Overall?
Name, overall. Name. It's what is called. So when we get the half an inch galvanized steel, is that the OD or the ID? When you measure it.
OD.
It's the OD, outside. So it could be really thick, so the inside might be different. So they are naming it after the outside. It's named half an inch because the outside is half an inch. When you go to copper, they will say half an inch. Is that the ID or the OD? That's the other way. It's the internal. So you can go and measure, it's not going to be half an inch, it's going to be more than half an inch. But the inside is going to be half an inch. Phones off, guys. Pay attention. So ID, OD, thickness, and what is the nominal? So that's important to know. When you go buy pipes, usually you get it sold to you by the nominal and the type. So a nominal half an inch steel is not the same as nominal half an inch copper. If you want to connect steel with copper, what are you going to do? You're going to buy a special coupling that will understand the difference between thickness. And if you go to Home Depot in the piping aisle, probably there's a plumber there and an expert. He can tell you this stuff. This is the nominal diameter. Elbows, it's a way to connect pipes. We have 90 degrees, 45, 180 return, T's, caps, crosses, and all sort of connections. And you can see them in the shaft as well. Connections and reducers, this again other connections. So this is an elbow, this is 90 degree, 45 will look like that. You, sometimes you would use that, I don't know why, but it's there. What else? T's. Caps. It's the size. And crosses. And there's also couplings.
It's two different kinds.
Yeah.
Yeah.
So what do we need couplings for? It has reverse thread. Because did you notice yesterday that when we thread, the threading is always in one direction? So if you thread two pipes in the same direction, how you gonna connect them together? You need a coupling, and the coupling will have reverse connection each side. So it's easier to connect two pipes. And there's a coupling where you can weld, yeah?
Or union.
Yeah, union.
So it connects pipes that are going the same way?
Yeah. Reducers and connections come in big, small, and they come in different shapes. But this is a reducer. More information. Again, I spend a lot of time in power plants and refineries, so I know a lot about pipes. So this is just a lot of information that you might need for residential. What's a flange? If you are doing power plant, probably you know about flanges. A flange is an end of the pipe that connect two pipes together using bolts because you need a lot of pressure. So that's a flange.
Oh.
Let me go this.
Also that metal piece on it.
Oh, I see.
So it's a flange pipe. So you put faces together, you put a gasket between them, and you tighten it up.
Oh,
Usually for high pressure.
Oh, those are, okay, big boilers.
Yeah, it's
Okay.
for high pressure equipment because you need a lot of pressure to connect those two together. The thread is not enough. Bolting is how you connect pipes together. And again, if you are taking power plant, you will learn about bolting, flanges, and so forth. You connect it together, there's a bolting procedures, and there's a bolting size. Pressure rating is very important. You'll see that on copper pipe. That's how much pressure you can go through them. Otherwise, they start leaking or they burst. Mostly you will worry about that when you do steam, because steam has a lot of pressure. So make sure you be aware to the pressure rating. Some best practices, this is the stuff you will learn when you are apprentice. A lot of it is common sense. Like if you're connecting water, you want the tilt to be where the water is supposed to go. Don't do the wrong pitch. A lot of times you want to use 45 instead of 90 degrees because 45 is less friction. You can tell that when the water go through a 90 degree, it will lose a lot of momentum. And you will see next year when we design a hydraulic system, how it is kind of important to reduce the fluids. If you have a lot of 90 degrees, you're going to lose a lot of pressure. It's going to hit and go different direction. Use a water level. The eyeballing privileges are reserved for trained plumbers, but you need the water level because sometimes you really hard to predict. Layout plan. Before you cut pipes, you should have a layout plan with measurement. And again, those things come with experience. You have to account for the thread, and that's why they require you to have 5,000 hours of apprenticeship. Because these stuff, it's kind of an art, not just something you learn. But you can tell from a house you go and you see some really ugly piping jobs, where pipes going everywhere, pipe going through a wall, because somebody did not plan it very well to have the pipe the right way. And if you have the wrong piping layout, you might have more bubbles coming in, more possibilities for leaks, and more vibration. Right type of connection, tape or solution. So when we connect pipes, we use sometimes Teflon for water. That's to seal between the threads, because there is still some kind of gap between the threads. So either use tape, make sure it's the right tape for the material. Teflon usually for water. Oil has different kind of tape and different kind of paste. Make sure you have the right connection. Yeah.
For the tape that you're talking about, does it normally look white?
Yeah, that's the Teflon one. And they also have gray ones. You have to read what product's used for. Pressure and water weight inside the pipe. That is also something you have to think about. There are a lot of guidelines because water is very heavy. Water is around 1 pound per pint, so it's a lot of weight. So if you're gonna put a big pipe that's empty, it looks really good for you, but once it's full, the water's gonna sag. The weight will take a toll. So every 6 feet, I want you to have support. And there's something called a piping schedule, which tells you which pipe require how much support when it's full or when it's empty. So we talked about diameter. What's the radius?
Half the diameter.
has a diameter. So that's diameter. And half that is from here to here. That's radius. Radius. Ductility, elongation, deformation, these are all names for the material property. Ductility, what does that mean?
This is how sturdy it is.
How stiff it is? Like that, what is the opposite of ductility?
Rigidity?
Huh?
Rigidity?
Like brittle.
Oh, yeah.
So brittle is very strong but easy to break. Ductile, more malleable. So this is ductility. Elongation, it's how possible it is for the material to expand a little bit. Some metals you can expand actually. If you hold a long pipe, you can wave it. It does wave with you. It has some kind of elongation. Deformation is how much power is needed to bend that material. So the ability to bend and deform and doesn't come back to its own original state. So you can bend the pipe a little bit and come back to the way it was. But if you bend a little bit too much, you have exceeded the limit and it will not go back. We talked about erosion and corrosion.
Wait, can you go back on explaining what ductility and elongation?
Ductility is how malleable the material is.
Okay.
Malleable mean how is it willing to bend. So brittle, when it's too stiff, too hard, like carbon steel. Ductile, that's iron. You can bend it, you can bang on it and it will leave a mark. So that's ductility. How resistant it is to bending and reshaping. Elongation, its ability to be pulled,
So expanding.
expand and be pulled. Deformation, again, it's another property of how it's easy for this material to deform. Again, in power plant, if you talk about boilers, they will have description for all this material because it has to do with building a boiler. So for heating and we use plumbing for HVAC for heating pipes and radiators. You're gonna do that at some point. You're gonna pipe the whole thing from the boiler to your radiator. That's your job, and you can do that. And you don't need a license for that. You need your oil bearing license. Water connection. How do you connect with the municipal water, and also how do you have a drain, because you will need to flush the system once in a while. Steam. If you do steam heaters, you will have a lot of piping. Galvanized steel go all the way to the steam radiator. Drainage and more. There's a lot of drainage that has to go through from the boiler to drain the water and change it. So again, it's going to be a circle. The water you put in the system for hot water system, usually just circulate the whole season, and every season you have to flush that system. Kind of like your car, right? Your radiator has to be flushed every once in a while. I don't know how many, 20,000 miles or so.
Oh, really?
So there's always going to be a drain. Okay. Pipe connection, threads, they can be inside, they can be outside. Outside from the pipe, inside in the connections. We only do the outside, that's our expertise. Outside is called threading, inside is called what? Tapping. There's different equipment for that, you can tap into things and make threads. Again, this is a lot of stuff that pipe fitter will do, what are we gonna do here? Most fittings are pre-threaded, so the fitting comes already pre-threaded. And the thread size is standard, should be the right thread. Threads are always universal. The pitch means, like, if I talk about a thread in a pipe, if this is a pipe, this is my thread. So the pitch is the angle here. If you change the pitch, it's not going to go correctly, and it's going to, what do they call that? Stripping it. You will strip the cross thread, and also you know the thread if the pipe is soft. So we only do the outside. Most fittings are pre-threaded. Thread is universally pitched. What pitch and angle per application? That depends on the piping and the yeah.
How can we determine the threading of a pipe?
It's based on the application. So all steel have one pitch. Different application will have their own thread, so every industry have their own pitch and they stick with it. Did you notice that all light bulbs are the same thread? So they make it all the same. Light bulbs are all the same. So somehow the industry determined this, so that's what we're gonna use. We're gonna keep it universal. So mostly for galvanized steel, they have the same pitch within reason. If you go to different galvanized steel, say power plant, they have different smaller pitch, but that's gonna be again universal. These are the pipe threads, as you can see, nominal. It's the number of threads, pitches. I don't think you need that unless you're a plumber, but at least you have it in your information. These are the most common threads and their pitch. And depending on the number of threads per inch, so you can have it very fine or very big. If you notice also, if you walk to your car at all ranges are the same. There are two types, either metric or imperial, but mostly they are the same. Again, this is the picture of the pitches and threads. This is where we're going to do the pipe fitting. We have a lot of connections. We have 3 of those vices. I will show you how it's done. Do not use this. You can use this as a grip, but do not use this machine because it's predated. It works, but it's very unsafe. So don't plug it, but you can use it as a grip. This is the new machine that we got 2 years ago. Very easy to use. I'll show you how to use it. And probably every plumber has one of those. They have a compactor, a smaller size, but even easier to move. But they're very expensive, and they're worth the money. You see how, if everybody, for those who did the lab yesterday, you saw the difference between 15 minutes doing the cut of thread until like maybe less than a minute. So it's easier, and also your arms will not get as sore. So what are we going to be using? Thread bit. That's what goes into the pipe. Bit holder. So this is the bit holder. And the bit goes in here, and it has to go on the sides, for example, ½ inch or whatever. Grip vise is where you're going to put your pipe. It has to be in 3 places. If you hold the pipe in 2 places, what are you going to do? You might crush it and bend it. We need some thick gloves, no latex. And we're gonna work in pairs. We can work alone, but it should be, you can do it alone now. We have enough equipment. Please be careful, the bit is very heavy. You can fall on your foot. So make sure you have sturdy shoes. It doesn't have to, but if you fall, at least you're safe. One of them fell on my foot yesterday, but I had safety shoes. Yeah. So be careful. And again, this is really going to be really fun to do. Just let's take our time and enjoy it. We have lab coats, so wear long sleeve. The pipe might fall in your hand. So thick gloves, goggles, and long sleeve shirts, pants, and safety shoes. Some fun videos if you want to watch how they make elbows. It's from Science Channel, how it's made. It's really fun to see how elbows are made. Okay, I think that's all the information I have for piping. The rest we'll do in the lab. Thank you.